Hello everyone. So the first thing I want to do actually is explain to those of you who haven't finished it yet how to finish the Sierpinski triangle. So I was encouraging you in class to not worry about the recursion at first, but just to see if you can draw the first three triangles that would be subdivided in this thing. So I want to draw this triangle in the lower left, right, like that. And I want to draw this triangle in the lower right. And I would want to draw this triangle up top. Now what I have to do is find the coordinates of these three new points that I've created, and then I'll be good to go. So what I find is that, well, actually, the way to do this is to go halfway in between each one, which is to average the coordinates. So the x-coordinate of this one down here would be x0 plus x2 over 2, and then the y-coordinate would be y0 plus y2 over 2. And then you can follow very similar things for these other ones. So this one would be have an x-coordinate, it's between x1 and x2, so it would be x1 plus x2 over 2, and y-coordinate between y1 and y2. And then this one here would be x0 plus x1 over 2, y0 plus y1 over 2. Okay, so now we have all the coordinates we need. Now it's just a matter of doing this in code. So I've already got a method to draw triangles, so I'm just going to have to call that a couple times. So I was drawing the triangle and the whole thing before. Now let me draw it on these parts. So I just want to put the code side by side here. Let's see. Okay. So let me draw the bottom left first. So say draw triangle. So it's got the points x0, y0, but then x0 plus x2 over 2 is my x-coordinate, and then y0 plus y2 over 2 is the y-coordinate, my second point. My third point is actually this one, x0 plus x1. So you know what I'm going to do? I'm going to define some extra, to make this code a little cleaner. Let me call this point down here A. I'll call this one B, and I'll call this one C. So let me define some auxiliary variables here. I'll say, let me make, first we'll say int cx equals x0 plus x1 over 2. cy equals y0 plus y1 over 2. And I've got int ax equals x0 plus x2 over 2. Ay equals y0 plus y2 over 2. And then b, I don't know why I did c first, but b is x1 plus x2 over 2. And by is equal to y1 plus y2 over 2. So let's see, did I get them all? A, B, C, x, y, x, y, x, y. Okay. So the first triangle goes C, x0, y0, A. So let's just do that. So I'll do CX, CY, x0, y0, AX, AY. Let's just, before I go any further, remember I always say test incrementally. So I just did one little new thing. Let me just see if I get this lower left triangle. So I'm gonna build this real quick. I'm gonna run it. It says unused because I haven't used everything yet. But when I run this, it's gonna output an image, and that image looks like this. Okay, good. So we did get the lower left one. Let's try to get the lower right one. So that would be A, x2, y2, and B. Oops, so I'll say draw triangle, canvas, AX, AY, x2, y2, bx, by, with a thickness of 1. Okay, let's just, again, incremental test. So let's see, did I get the lower right one in there now? So if I reload this image, good, I got the lower right one, okay. Finally, I'll do the one up top. So I'll say draw triangle, canvas. That one's got C, B, and X1. So CX, CY, BX, BY, X1, Y1. Thickness of 1. Okay, let's just check this last bit here. So when I open it up, I see. Good. Okay, so that's the first step, is to get this first subdivision here. Now's where we have to make a conceptual leap. And we have to realize that, okay, I did one step of this thing, but I need to keep going. But when I think about the Sierpinski triangle, really, you can define it in terms of itself. What you're saying is the Sierpinski triangle is itself copied 3 times. The first copy is in the top, the next copy is down here, and then the other copy is over here. So instead of drawing 3 triangles, well, I can draw 3 Sierpinskis instead. So, and I want to do this, I don't want to do this forever. Technically, mathematically, it's defined as going forever, but for my drawing, I'm just going to go up until this maximum depth. So what I'm going to say is first of all, if my depth that I've passed into this method, if my depth is beyond the maximum depth, then I'm going to stop. So I'll only do anything if depth, after I've drawn the triangle, say if depth is less than or equal to max depth. So I'm only going to keep drawing the Sierpinski if that's the case. But here's all I have to do. I just, instead of drawing a triangle 3 times, I'm going to draw Sierpinski 3 times. That's what I told you the Sierpinski triangle is, right? So just like the Fibonacci sequence was the sum of 2 numbers in the Fibonacci sequence, the Sierpinski triangle is really the union of 3 Sierpinski triangles. And I already figured out their coordinates because I drew them as triangles. I drew the boundary of each one. So I just replaced with the draw Sierpinski. The only argument that's different is the very last one. For the triangle, this was thickness, but for here, the argument is depth. So I want depth to say how many times I've gone down into the subdivision. So I should pass along what my depth was last time, plus 1. So that's it. Once I knew how to draw those 3 triangles, I just insisted that, well, instead of drawing the 3 triangles, I'm going to draw 3 Sierpinskis. And the recursion takes care of it for us. There's no loops. How cool is that? Well, first let me show you it actually worked. So I'll make this, and I will run it, and let's take a look and see. Boom. There we go. There's our Sierpinski triangle. So this did a lot of work for us with pretty little amount of code. If you like this, I would encourage you to keep going and trying other examples. So, as I mentioned briefly yesterday, there's something called the Koch curve, which I've linked to below this video. And it's a way of starting, instead of starting with a triangle, you start with a line segment. And you divide the line segment into 3 parts. And in the middle part, you actually, that's where you make 2 new ones. And then you keep going. So I'm not going to say too much. I'll send this link, but this is like the next thing to try. Or you could also try the Sierpinski carpet. This is a little more similar to the Sierpinski triangle, but it's with a square instead of a triangle. So yeah, so mess around with those. In the interest of time, I'm going to move on to some other examples of recursion. But I feel like this one went pretty well, and that people really liked it. So that's great. All right, so let's proceed to the next topic.